This video is talking about logic statements, and the first thing you need to know when we start talking about logic statements is a little bit of notation. So you'll see that we have P's and Q's here and in our chart, and we need to know what those P's and Q's are in order to effectively learn the rest of what we're going to learn. So our P is a hypothesis. Our Q is a conclusion. So I'm just going to dive right into it because I think it's the easiest to learn when you see some examples. So the first example is I get good grades when I do my homework. So if I think about that statement, it sounds like the hypothesis is if I do my homework, the conclusion is I will get good grades. So the P, hypothesis, is doing homework. And the conclusion is getting good grades. So each of these statements is a different type. So we have conditional, converse, inverse, and contrapositive. And we're basically switching around some orders and adding some knots. But the important thing to remember is that when we're dealing with logic statements, not every statement we make will be true. And I'll show you kind of what I mean when I say that. So we'll start with the conditional statement. So conditional statement, this is the symbolism for it, P and then an arrow to Q, which stands for, or is said, if P, then Q. So P is my hypothesis, which is doing homework. So I would start my conditional statement with, if I do my homework. And then it says, then Q. So then my conclusion is I'll get good grades. So if I do my homework, then I'll get good grades. So that's my conditional statement. The converse, instead of doing if P then Q, does if Q then P. So I'm going to start with my Q, which is getting good grades. So if I get good grades, then I'll do my homework. So this one seems a little counterproductive, right? Because you might not get good grades if you don't do your homework, so it seems a little bit backwards. So again, like I mentioned earlier, it might not necessarily be true. We're just talking about different logic statements and what they're called. Our next one is an inverse. Now this little symbol right here, you can't see it very well on the screen. It's a little squiggly line. And this little squiggly line means not. So if not P, then not Q. So we're going back to my original order. So if I don't do my homework, then I won't get good grades. And that makes sense. May not necessarily be always 100% of the time true, but that's a logical statement to say. And then our contrapositive is if not Q, then not P. So we're going to switch that order again. If I don't get good grades, then I don't do my homework. So more than anything is it's kind of a definitional thing, but this is going to be really useful when we start doing proofs because we need to be able to make logical statements from one thing to another. If this is true, then this is true, then this is true, and so forth. So I think this is a really good thing to practice getting your mind in a logical framework to be able to prove things. But let me show you one more example. So the next one, example 2, is snakes are reptiles. So my hypothesis is that it's a snake. We're going to say it's a snake. And my conclusion is, well, if it's a snake, then it's a reptile. So that kind of gave away my conditional statement right away. If it's a snake, then it's a reptile. And that's true, right? Snakes are reptiles, so that makes sense. Now and this was if P, then Q. Now our converse goes the other way. It's if Q, then P. So we're going to go backwards. If it's a reptile, then it's a snake. And that's not always true, right? That could be true, but there are many reptiles that are not snakes. And then our inverse is if not P, then not Q. So if it's not a snake, then it's not a reptile. And the last one is not Q, then not P. So if it's not a reptile, then it's not a snake. So I'm going to go through and see which of these ones are a little bit easier to see if they're true or not. Doing my homework and getting good grades, it's a little bit hard because generally, yes, if you do your homework, you'll get better grades, but good is kind of up to the beholder. Some people think an A is good, some people think a C is good. So it kind of depends on the person. So it's hard to decide if those statements are true or not. But this one's a little bit more straightforward. So if it's a snake, then it's a reptile. That's totally true. If it's a snake, it's got to be a reptile. If it's a reptile, then it's a snake. Well, not always, because there could be another animal. If it's a reptile, there's other reptiles, like crocodiles or alligators. It could be a crocodile or an alligator and not a snake. And then there's an inverse. If it's not a snake, then it's not a reptile. Well, that's not necessarily true because it could be a crocodile and then it would not be a snake, but it would still be a reptile. And then the last one is if it's not a reptile, then it's not a snake. Well, all snakes are reptiles, right? So if it's not a reptile, then it's not a snake. That's true. So it kind of just gets you in that mindset of thinking logically and does this make sense? Does that make sense? And that is the biggest thing that you need when you're proving things is you just have to make a logical sequence and make sure each of your steps make sense.